number 4
Yes.
is absolute value. All right, so first off, you need to isolate what's in the absolute value bars. So you've got to perform algebra to get rid of the stuff that's there. So what's the first step? Add 1. Now you have 1/2 times the absolute value of 2x minus 5 is greater than 7. Now you need to get rid of the 1/2. How do you get rid of it? Multiply by 2. Now you have the absolute value of 2x minus 5 is greater than 14. Now is when you remove the absolute value bars. This is greater. Less than. Okay? So this is a or problem. Okay? Greater. If it had this symbol, less than. Okay? So, the most important thing to remember about absolute value is you're solving 2 equations. You're solving 2 inequalities. There's always 2 of them, not just 1. Okay? So, 2x minus 5 is greater than 14, or 2x minus 5 is less than negative 14. Add 5. 2x is greater than 19. Divide by 2. X is greater than 9.5. Or add 5. 2x is less than negative 9. Divide 2. X is less than negative 4.5. So here's your 9.5 with 9 and 10 on each side, and here's 0, and here's negative 4 and negative 5, so negative 4.5. X is greater than 9.5, open circle at 9.5, and everything to the right. X is less than negative 4.5, open circle at negative 4.5, and everything to the left. N is the absolute value of something greater than a negative number. Always. So guess what the answer is? All real numbers. This is the type of problem we like to put on the multiple choice. Did everyone see? No work needed. When is the absolute value of something greater than a negative? Always. 2x plus absolute value of 2x plus 5 less than negative 1. When is the absolute value of something less than a negative number? Never. What's the answer? No solution. Okay, someone has an equation for me. I want x on both sides. Yes.
3. No, yeah.
3.
And then absolute value x over 9.
X over 9?
Yep.
Okay.
Absolute value is closed. And then plus 7 equals 8x.
First step. What's the first step? Subtract 7. 3 times the absolute value of x over 9 equals 8x minus 7. What do you want to do now? Divide by 3. Divide by 3, divide by 3, divide by 3. I'm going to divide each thing by 3 separately, including these. Okay? Now I get the absolute value of x over 9 equals 8/3 x minus 7/3. Now think of it this way. If the absolute value of x equaled x minus 4, you would say, well actually let's make it even easier. If the absolute value of x equaled a positive 3, what would be the 2 solutions? X equals the positive version of the right side, and x equals the negative version of the right side. We're going to apply that same idea here, okay? So we're going to say x over 9 equals the positive version of 8/3 x minus 7/3. And then we're going to say x over 9 equals the negative version of 8/3 x minus 7/3. Did you kind of follow what I just did? Okay. What makes this really messy are all the fractions everywhere. Okay? Everybody get this? If the absolute value of x equaled 3, x would equal a positive 3 and a negative 3. What about this one here? X equals the positive version of the right side. X equals the negative version of the right side. Are you watching that methodology of solving this, right? The positive version of the right side and the negative. It's just kind of messy here with all the fractions. This is x over 9 equals 8/3 x minus 7/3. What can we do to this to make our life easier? Get rid of the fractions. How are we going to get rid of the fractions here? Multiply everybody by 9. A 9 for you, a 9 for you, and a 9 for you. What happens here? The 9's cancel, leaving us with x equals. What happens here? The 9 cancels with the 3, leaving a 3. 3 times x, 24x. What happens here? The 3 cancels, minus 21. Isn't that better to look at? Okay, now subtract x from both sides, add the 21. You get 21 equals 23x. This is a terrible problem. Divide both sides by 23. X equals 21 over 23. X over 9 equals what? What about this one? Negative 8/3 x plus 7/3. Do the same thing, multiply by 9. X equals negative 24x plus 21. And you get negative 25x equals 21, and x equals negative 21 over 25. You are much more likely to see a problem that looks something like this. The absolute value of 2x minus 3 plus 5 equals 4x. You're much more likely to see something like that.
Put it up, please.
Okay? That's far more what it's going to look like on your free response. Okay? What would you do to this problem?
Let's do it.
Well, now, the only thing is, I don't know what the answers are, and we try to make at least one of your answers not be a fraction. Okay, but the setup on the problem, more like this. Not all those fractions. Always go back and check. Okay? There are 2 standards this semester that you have to go back and check. One of them is essential standard number 4, the one we're doing, absolute value. And the other one is essential standard number 7, radicals. Those are the 2 problems that you have to go back and check. The setup on this one would be what? Subtract 5. The absolute value of 2x minus 3 equals 4x minus 5. Whatever you do, don't forget 2 equations. 2x minus 3 equals the positive version of the right side, or 2x minus 3 equals the negative. They're going to think it's 4x minus 5 and 4x plus 5, right? So to get this right, it's the positive version of the entire right side and the negative version of the entire right side. Then distribute the negative. Can you see how that'll make it easier to do? It's equal is when you check. You check equations. You check radical equations and absolute value equations.